All right, so this is what we did last time. Is about a very simple, what we call single inheritance. So we have a derived class, we have base class. In this example, we call label GPS, which is the derived class. They inherit everything from GPS DD. All right, so I made some changes to the source code. If you already download CPP04, there's some additions to that repository. So we're looking at this now. I'm representing a little bit different picture. So I'm using the object representation. So an object is essentially some attribute in this boundary. And then we have what we call interface or member function that you can call this member function to access to that. So one of the things we did is about constructor. When you handle single inheritance or multiple inheritance, the same. You need to connect the constructor from the derived class to the basic class. In fact, you need to find that such that the program will get enough information to initialize all the component of the object. So here we have to think about this is that without inheritance, an object is an object. But with inheritance, sometimes the object will have, in this case, an object has two components. One component is essentially the derived, and then the other component is the base. So essentially from now on, when we learned about the concept of inheritance, you will realize that your object might have a multiple component that for you to handle. So you will see here, I'm actually worried about constructor. That's why I need to know that each of the component in the object I'm dealing with right now, how do I invoke all the components constructor in order to do everything correctly? Okay, this picture shows what we discussed last time. So when you want to call the constructor, you first call the base constructor. And after that's done, then you come back to really invoke the derived constructor. So always go all the way up to what we call inheritance hierarchy. And then from there, you're trickling down and then try to initialize everything. And also, now you start to see the three keywords. You have private, protected, and the public. You have three different sessions. So there are not only you can specify private, protected, public inside this pair of curly bracket, but you can also say this in the inheritance relationship. You see here, when you do single inheritance, you can say class derived. After colon, last time we just say base. In our example is GPS. But between the colon and the base, you can insert what we call mode. Okay, this mode has three possibilities. The mode could be public, the mode could be protected, and the mode could be private. So if you define a mode, that is public. What does that mean? Means that the base class, anything in the protected area will be considered in the protected area of the derived class. If anything in the public area will be considered as a public area in the derived class. If you define that inheritance with the mode public, we'll see some example. All right. And if you define the mode as protected, then if you have either protected or public in the base class, in the derived class, it will be under protected. So which means that if you have something, a member function for the base class that was public, but now you want to inherit, but with the mode protected, then for the derived class, those public method is no longer available to any object or any code outside. However, since it's protected, still there is a derived class of the derived class. They can still access to that. So that's the usage of protected. If you want to somehow create a class, but you don't want the base class to be public. Any question? Okay. So again, if you define as a private, that means anything from the base class that's either protected or public, it becomes private. So essentially, this mode mandate what should be the access for this information on the right-hand side. Okay, that's a detail. There are cases. By the way, when I wrote program, I realized a lot of us, when we do single inheritance or multiple inheritance, public is the most popular mode because it's simple. You can still use whatever the public mode in the base class, and therefore it's your object, say label GPS, you can still let other people access. Protected mode, in some cases, that's actually going to be useful because you want to change the access modes to your base. And that's has some good application. Private, to be honest with you, I personally I never use private mode because private mode kind of restrict a lot about how I can access to this object. Okay, so that's the mode. By the way, I do want to say that in the mode, in the same area, we're going to put mode. We're going to introduce another keyword called virtual. So essentially, you can access to say that inheritance relationship is a normal inheritance or it's a virtual relationship. That's why there is a difference. Later, we'll see the difference between multiple inheritance and virtual inheritance. They're both looks like it's a multiple inheritance, but they have a significant difference semantically about the language. Okay. Okay, any question about the basic, about the relationship between child class and parent class? Okay. All right, one of the things I want to start worry about is that, okay, if I have a inheritance relationship like this too, between say GPS, DD, and the label GPS. So one of the things we need to worry about, in fact, some of you did ask questions after our lecture on Monday. Thank you for start probing this part of the lecture. The thing is that if I have really two components, so now we're talking here, I'm here in the derived class. I have two components, which means that I sometimes need to go up and down. So when I say in the inheritance, I say go up means that I want to climb up from the derived class of the component to move to the base class component. So why do I need to move up? I typically wanted to move up with two reasons. One is I want to call a function that's actually being defined at the base class. I want that to be, especially if that function has the same name as a derived class, which I will show you the example. By the way, if that function is unique, means that the derived class didn't have it, so it's good. You can, when you call that function signature, it will automatically go up. That's true. However, in I should say that in object-oriented programming, it's always benefit to explicitly to say I want to call the parent version of whatever function. Even that function signature is unique in the whole inheritance hierarchy because you don't know when somebody else modified the code. and such that there is a new function got introduced, got inserted into the inheritance hierarchy with the same function signature. In that case, you thought you're calling whatever version, but it's actually calling the other one. That's why from the programming perspective, especially when we deal with inheritance, it's always good to be explicit about what function you're calling. It's just like a this. When some of you ask the question, why do I always put this hyphen greater than? That's because this is a pointer. Why I always use this? In a lot of cases in my code, I can remove this hyphen greater than and just use whatever, for example, latitude and longitude. However, when the program, the complexity grow, you really have no assurance that when you say latitude, it's really this latitude or something else that somebody else defined. So therefore, to write a really good program, especially in object-oriented programming with the possibility of inheritance, is good always to do explicit. And when I say explicit, I really mean casting. You will see when I did this everything I did is for using a tool called casting. Okay, so now you see that I want to move up and move down because I want to access different components. And sometimes I want to access the method, whatever function I define in the base class, or sometimes I want to access the data itself, the attribute itself. Okay, so that's why I want to move up and move down. So now I'm going to spend next probably 5 to 10 minutes to tell you how to move up and down. That's very important. Okay, so by the way, just to let you know, this is I update the file under label gps.h within CPP04. I add about 4 or 5 questions here. You can see that at the end I said the above questions are pretty much all we need to worry about for the next midterm. Okay, so this part I just tell you that if you understand this concept, basically you will do really, really well in the next midterm. Okay, so the first question I already covered is how to define a single inheritance relationship. And I mentioned what's public, what's protected, what's private as the mode, as I mentioned over there. And then I mentioned the keyword virtual, but I haven't gave you any example, which I will very soon. And the second question I'm now trying to introduce is actually how to move up and down from a single inheritance hierarchy. So that's the question I want to address right now. Okay. Let's look at the program. Test. Okay, this is a program I show to you on Monday. However, I make some changes. So still the first few lines, essentially I define, let me make it bigger to, okay, now I feel happier with this. So the first 3 lines, I define 3 objects. They are all labeled GPS object. Okay, they're all labeled GPS object. They're all derived class, but they are, how do I say that? They're derived class, but they have 2 components. One of the component is indeed labeled GPS, but they all have the other component, which is GPS DD. Okay, so I add, okay, let me go back to show you this one. If I look at the declaration, which is under label GPS.h, I want to show you that I add 1 line, a function in the function called, look at this function. This is a function foo. It doesn't take any parameter, only, it doesn't return anything, but I just for simplification, I directly add the code here. Okay, so look at this is a member function, and with the implementation, I can put it in the .h file. Look at this line. This line is just stdcl label GPS \n. So what this function is really doing is just printing the class name of this particular class. And the function I call the foo, right? I just basically call this function. So I also have another function looks like this in GPS.h. This is the base class declaration. And then I also have this foo. It's the same signature, function signature of foo. And the only difference is implementation. The implementation is that printing out the name of the class, which is GPSDD. So essentially, the semantic of foo is if you call that function, is going to give you the class name of that particular object. All right, so if you call the, by the way, you probably notice that now I have a base and the derived, and they have the same function called foo in both of the component. So if I call the derived, it will give me label underscore GPS. If I call the base, it's going to give me GPSDD. Okay, so that's the example I kind of illustrated earlier to talk about the same function signature, they appear. So then we need to move up and down, meaning that we should have the control about which function we would like to call. Okay, so let's try to see how do we do this. Okay, so let's take a look at that. Take a look at this two line. I want you to take a look at this two line. My first question is, do you think this two line will give you, will let your code to call different version of foo or the same version of foo? Just look at this two line. Do you think you're going to call the same function or different function? How many of you think you're going to call different function? Okay, some of you raise your hand. Others, you're still trying to figure out, yes, this is going to call different version. One of them is going to call the derived class. One of them is going to call the base class. Base class is GPSDD. Derived class is label underscore GPS. And why is that? Because you can see that I'm actually using the object. What is the object? GPS TLC UC Davis, which was the second object I create. When I create the object, is labeled GPS. So I know I have two components there. Of course, when I say I know, means that the compiler knows as well. All right. So when I call this, I put the object.foo, because what's the type of GPS TLC UC Davis? It is label underscore GPS. Therefore, when you call this, is immediately is going to call the version of foo that's associated with labeled GPS. So how does a compiler realize which function to call? Look at the data type or whatever, class type, object type. For the object, you try to invoke that foo. So this, obviously, that's why I said it's explicit, because you have to find a way to tell that that is the data type you want to call. Okay, let's look at the next slide. The next slide, I play a trick called casting. You probably see me doing this a lot. So this is the original object. What's the type of that object? The type of the object is label.gps. Well, but I cast it with GPSDD reference. Okay, so now I'm using reference. But sometimes, in some cases, you might not need this reference. But let's actually just use the reference. When I do a reference, I basically convert that object, GPS TLC UC Davis, and then I turn it into an object, that's actually GPSDD. In this specific case, in fact, the data type is not even GPSDD, is GPSDD reference. By the way, this is a really hard topic. You will gradually understand under what situation I need to add an N, add a reference, under what situation I shouldn't. And by the way, there is pretty complicated situation. Even today, you will see that why I said that. It's really the experience and the way you have to write small program to test it out. Whether that's the case, you should use reference or object. That's why as a C++ programmer, especially when you deal with inheritance, you really need to verify. You need to write this kind of small program. So, okay, over here, you can see that I'm casting the whole thing. So now I change the GPS TLC into a GPS DD, and therefore the whole thing under this parenthesis, the data type has changed from label GPS to GPS DD. And therefore, when you call foo, the compiler knows that, okay, wait a minute, this is going to be a different version of foo, which I need to go up to the base class to link the right function to execute. Okay, so that is basically the function call. If you have the same function, let's just yes. Yes, you need to have that. Assuming GPS DD and label GPS, they don't belong to each other. And the thing is that when you try to call the function directly doing this kind of casting, when you do casting, it's already will give you at least a warning. A lot of time it will give you an error. So, okay, I take it back a little bit. So there are multiple cases that you can cast something. Sometimes when you cast one to the other, it doesn't have any inheritance relationship. You can do that. For example, you can cast integer to a double because the compiler built in to allow certain kind of conversion. But in general, when you have an object with a class with the other class that didn't have any relationship, when you do casting, the compiler will actually complain, saying that, hey, you cannot do that. Okay. There are a few exceptions, but your question is excellent. Okay. Yes. Sorry about that. Say it again. What do you mean by dereference the base class? Okay, so good question. But you're talking about the pointer representation, right? So any pointer representation, no matter how we do, the data type for that pointer, it must be pointer to something, right? Pointer to the GPS or pointer to the label GPS. So whatever pointer you have, assuming this is a pointer, okay? Whatever that data type is, if that pointer, by the way, first I want to clarify, if it's a pointer, the syntax has to be, because I saw a lot of you kind of confused about that. If it's a pointer, the syntax always like this, right? So let me just get rid of this. So every pointer still have a data type. Therefore, if the data type is a pointer to the GPS DD, then it will call the base. If it's a pointer to the label GPS, depending on how you declare the pointer, you can also casting the pointer as well. Okay, so that's always look at the data type before you hit the function for us to decide which version. Okay, so data type mandate everything. But when I say this, later I'm going to introduce another concept called virtual. And when I do virtual, then the data type doesn't matter. Okay, Yes.
I have one question. When we typecasted GPS Davis, is it now just like of the class type GPS DD, or does it also retain its derived class, or is it both a GPS DD object and a labeled GPS object?
You said this one.
Yeah.
When I cast it, right?
Yeah, like we cast it to GPS DD,
right.
So now it's like
okay.
Now it's
If I cast it with the reference, it has both component. But if you without this and we'll show you an example, you actually only the base portion of the object stay, and the derive is gone if you do a copy, because that's the difference between how do you access object as a reference or as a copy. Okay, so call by value, call by value is essentially copy, right? So I only copy that portion. I will show you an example to see how this works. Okay, all right. Any question for this two line? Okay, I'm going to just run the program very quickly. You should do that whenever you have time. Okay, I'm going to run test label. Okay, it's a lot of things, but I want to tell you what this two line. The first two line is this first two line. Oh, no. Yeah, this is the first one because the foo, right? Foo is just print the class name. And the first foo is output, label GPS. It should be labeled. I misspelled myself. And then the second one is GPS DD because I call the base class. Okay, so this just verify that whatever I just mumbling for the past 5 minutes, you can write a program with a few lines of code. Okay, don't trust your instructor. Always, okay, write your own program to validate whatever I said. Okay, it's very important. Yeah.
Something, does the cast apply to the rest of the code or just that one?
Only to that line. When you cast, is only to that particular position. It's a good question. Yeah. Okay, by the way, if you want your cast to have a more permanent effect, there's a way to do that. Usually we will declare another variable to assign into that. And subsequently, you just use that variable, which is include the result in casting. That's respond to the part. Okay, so now let's do a little bit more on casting. Not here. So I'm going to move up and down right now so I can access to some different portion of the file. Okay, so let's take a look at this three line right now. So this three line, in fact, it's only two line, right? The one line is comment. Let me try to change the highlight. So here I'm just doing a move up and down because what I want to do is not only I can move up, I should be able to move down as well from the base to the derived. I need to go both ways as a programmer, and C++ allowed to do that. However, I would say that the most natural way to do move up and down is always use reference. Don't use copy, because when you do copy, you're going to lose some of the component, especially when you move up. If you're doing copy, the derived component is gone essentially. Okay, only the parent go up. Okay, so I'm doing up. How do I move up? I declare, you see that I declare a reference called GPS DD reference, and I give a variable name GPS reference. And see what I did? I do a GPS and reference, just like what I did here, right? I said, well, I casting with a GPS DD. So now I got the GPS ref. That's actually moved to the base component, the base portion of that object as a reference. Okay, in fact, I just want to tell you that reference, just like a pointer, is essentially move your pointer within your memory. It didn't do any copying, it didn't change any value. Whatever you had is still there. I'm just moving the reference point. So that's why when you want to go up and down, moving with a reference is actually very safe for you to do that. Okay, so now I'm going to tell you, I'm going to move down. I'm going to move down. So how do I move down? You see that this line is how I can move down. So what I have, what is a GPS ref? GPS ref is a GPS DD reference. And now I want to move down. That means I want to cast the derived class. So I do a label underscore GPSN to that reference. When I cast it with the derived class, now I can actually get my object back to the label reference one. I call it label reference one, which is a label GPS reference. Okay. I mean, the first line, you probably already guessed it should work, right? Because we saw how we can go up to call the foo. But the second line sometimes is very useful too. Okay, sometimes it's very useful too. And especially, let me tell you the most interesting, I shouldn't say most interesting, the kind of things I did for my project is assuming I do an Internet of Things. Internet of Things has so many different things that some of the things is just thing is my base class, but I want to come out with IoT thing, which all the device with internet capability, or I want to have a food, which doesn't have internet activity, but it basically has some kind of property about the thing. So I'm going to create, let me just use an example. I'm going to create two classes that both derived from the thing. So I have a thing, and then I can come up with IoT thing. And then I can also define another thing called food. Okay, so I have two derived class, one base class. So when I want to store an item, and I essentially move up, I move everything to thing, so I can have a piece of code, I can process all the stuff at the thing level. So I want to handle everything on the base level. But once in the base level, I typically kept it in the vector or kept it in the map. And that's standard C++ template. But then when at some point I realized I need to move down to the original data type so I can process through or process IoT thing. So in that case, I actually need to move down. All right, so move up and move down is a basic mechanism for you to do that. To move up is usually fairly straightforward, but move down, you have to know exactly which way you want to move down. For example, how do I know this is a foo, not IoT thing? Because then I'm going to casting differently. By the way, the compiler doesn't track in a lot of cases in C++. When you cast it down to a derived class, whether that's really the class you should cast down to, okay? I will show you some example. All right, so any question about this line, the casting down? Okay, good. So let's try to write some program. Okay, now let me see. I will do this to see the result. Why don't I do this? I will print the label, okay? Because I'm going to cast up and down. I want to make sure that when I cast down the label, because the label is a component of the what? The label is a component of the derived class. I want to see if I go up and down, my derived component is still there. So let's try to do this. I print before and after this casting. But after the casting, because I have a label, I will use this label reference one dot label. Okay, you see I print out two because GPS TLC UC Davis dot label was original. And this label reference one is go up, go down, and I want to print the label, whether they're the same. Let's try to see whether they will do the same thing. Okay, let's move up. You can see that this is the first two. We see it's print the food stuff. And then you can see that the next two line is both printing, teaching, and learning complex. So essentially, this verify with this programming, those two lines up and down, I didn't lose my derived component. Okay. Okay, now let's see if I do something differently. Now let's do something I call a move up with copy. So when I move up, I didn't use reference, I use copy. And move down, I have to do reference. Let me tell you why. So how do I move up? You compare this line and this line. This line over here and this line over here. What's the difference? Okay, as a C programmer, C+ programmer, I want you to be sensitive to even just one character. What's different between those two? This line and this line here. What's the difference? Yeah. Yeah, the casting had the reference. Now I remove that. So this is what I call a copy. It's no longer, I'm no longer casting that to a reference, but I'm actually casting that to a copy. And look at what I did. Okay, so this part is try to remove the reference. But if you try, you can try this piece of code. I also remove, if you compare this lines of code I highlighted here is the same as this one. These two are the same, okay, except one called reference, one called copy, but syntactically they are the same, except I remove the and. I try to do the same thing. And guess what? If you run this program, this line is going to give you a compiler error. The compiler is going to say, hey, you cannot do this kind of casting when you try to do is from a base class to the derived class. There is a reason for us not to do that, but I try to save some time. But I would like you to try it, because if you try to do that, it just compiler won't, because compiler doesn't have enough information to generate code for that line. I want you to think about what I just said, okay? All right, so let's try to, instead, I can write this way. I can write this way. So what is that way? This way basically say, hey, when I want to cast down, if you gave me a GPS copy as an object, which is a GPS DD, and you can cast it as a label GPS reference, and I will give you another label GPS object, which is I call the label copy one. Okay. Okay, now I'm going to ask you a bit tricky question. You see that before I did this go up and down, but now my up and down is no longer reference up, reference down. I'm doing copy up, reference down. That's all I can do based on the G++ compiler. Okay, so before and after up and down, see how I verify? I want to actually print the label. That's the same thing I did. So I print the original GPS TLC Davis label. At the end, I print labeled copy one dot label after the copy and down. So now I want to ask you a question. First question, do you think these two printing statements are going to give us the same result? How many of you think that these two printing statements won't give us the same result? Okay, some of you raise your hand. Why? Okay, Anybody else? Yes, please. Okay, okay. So both of you are correct about this. Okay, so you will get this the same result. They will going to be different. So the next question I want to ask you, if by the way, the best way to verify the answer is to write a small program yourself. Okay, to verify. That's always the best way to answer this type of question. But if we know that these two are going to give us different results, then what do you think the difference we will observe? What should be more specific? What do you think this line will print it for us? Any guess? And of course, you can write a program to verify, right? Okay, that's why I said is the best thing is let's try to print it and see what happens. Okay. So I didn't change any code, so I just run it. So let's take a look at this. So this line, this two lines were the first up by reference, down by reference. And this two lines are what? Are up by copy and down by reference. And before I did that, up by reference, up by copy, down by reference, the label was teaching and learning complex. And when I did up and down, see what I got? I got some kind of random stuff, right? I got some kind of random stuff. But what does that random stuff remind you? Let's take a look at the code, okay? Take a look at the code again. What did this remind you? Go up here. Okay. Yes.
That's the IKEA of Sacramento.
Right. The IKEA Sacramento is the object that's actually right next to it, right? So you can guess in memory that the location, the memory allocation for TLC Davis is going to be continuous after or before IKEA Sacramento. So in terms of the object location, they're the same. So therefore, when you have a copy up and reference down, you lost your what do you call the derived component, and yet you're attached to the IKEA Sacramento object. And therefore, the compiler just assuming your code is correct. You know what you're doing, but instead, your code is accessing a memory that doesn't exist. And that piece of memory was used by another object called IKEA Sacramento. So essentially, this is, by the way, very dangerous and very important lesson we need to learn about object-oriented programming, is that as a Python programmer, you never need to worry about that. As a Java programmer, you're very safe. But unfortunately, you guys are C++ programmer. This is the how do I say that? The ugly portion of the C++ is that the compiler allow you to do something, and yet you're going to get some of the result unexpected. By the way, if you make this kind of mistake in terms of writing code, what mistake we made? We just forgot to add the and sign. The only difference is just one and sign when you do up and down. And you're not only going to mess up your current object, likely you're going to mess up other objects as well, because they're all there. Okay, so that's why is a very, very critical for us to kind of know the difference. Okay, so we will see more. For example, how do I know more about what's going on? I'm actually going to print the address of each of the components. That's called memory layout. I want to see exactly what is the data. And then I want to see whether this memory address and the other object's memory address ever collide to each other. Then I know my program has a problem. Okay, that's why memory allocation, memory addresses become really, really a powerful tool for C++ programmers. But the thing is that that's more detail. I'm not going to do that. But at this moment, I just want to have a one coaching point. If you want to move up and down, as you learn from this lesson, always remember to put an M sign. If you want to copy, that means you never want to come down. So let me say, if you want to go up and go down, then you have to use reference both ways. But if you don't care about moving up, you only want to move, you don't care about move down, you only want to move up, then you may use copy for that example. Okay, does that make sense? Okay. I think I can cover, no, I don't have time to cover. Let me see. Yeah, okay. Why I have this GPS test here? Oh, you can do this as well. By the way, this is just a simple thing. You can actually declare a GPS object and also just reference move down. This is the same thing as previous we saw. Okay, so I'm going to stop here. And the next time, let me go back to my instructional plan. It's under label gps.h, is under GitHub, just to let you know. So we cover number 1, we cover number 2, and now we are going to move to number 3. Number 3 is basically how our objects, including those derived component or base component, allocated in memory. As you see that, they're actually putting together. Okay. All right. I will see you on Friday, and I'm going to stop recording and start distribute